Hello, my name is Mark Manotti, and in this video I will be walking you through my practical assessment on classification, which is part of AI and machine learning intermediate course. The goal of this project is to build a machine learning model that can predict whether a loan application submitted to a SACCO should be approved or rejected. We start by importing the libraries. Here we use the Pandas and the NumPy, which is used for data manipulation, while this one and Seaborn is used for data visualization. We import tools for splitting the data, processing and building logic regression model and evaluating its performance. As you can see, all libraries has been imported successfully. Here we load and explore the dataset called SACCO-learn dataset.csv. The dataset, as you can see, has 400 rows and 10 columns. Each row represents one loan application. The column includes features like age, monthly income, employment type, loan amount, loan purpose, credit history, repayment details, defaults. This one here. Repayment details, defaults, membership year, guarantors, and targeted variables for loan and loan status. In dataset info, this cell gave us a deeper look at the dataset. You can see the data types, the one listed here. For each column, some are numerical, like age and loan amount. The numerical, while others categorical, like employment type and loan purpose. We also check for missing values. We can use the monthly income. We can see that the monthly income, loan amount, and membership years all have missing entry that we will need to handle. Finally, the target variable loan status has 214 approved loans, while 186 rejected loans, which is fairly balanced dataset. This bar chart confirms the distribution of our targeted variable. Class 0 represents rejected loans with 186 cases, and class 1 represents approved loans with 214 cases. The classes are fairly balanced, which is good for our model as we continue. Handling missing values. In this cell, we handle the missing values in the dataset. For the 3 numerical columns, monthly income, loan amount, and membership year, we fill the missing values with median and each column. Of each column, we use the median rather than the mean because financial data like income and loan amounts tends to be skewed, and the median is more robust to outliers. After cleaning, we confirm that there is no missing values in the dataset. You can see that we have no missing value in the dataset. Go to cell 7, encoding categorical values. Machine learning modules work with numbers, not text. So in this cell, we convert all categorical columns into numerical values, all categorical column into numerical values using LabelEncoder for Scikit-learn. LabelEncoder assigns each unique category and integer value in alphabetical order. For example, employment type categories like employed, self-employed, and unemployed each get a unique number. The same is done for loan purpose, credit history, and guarantors. And for sale, we move to 8. Correlation heat map. As you can see, the heat map shows the correlation between all features in the dataset. Here, the relation between all features in the dataset. The color scale ranges from red to negative correlation to blue for positive correlation. We can observe the credit history and repayment defaults have a notable relation with loan status, suggesting that they will be important prediction in our model. Splitting features and targets. Here we separate our data into features and the target. X contains all the input features and Y contains the loan status. X contains all the input features and Y contains the loan status, what we want to predict. We then split the data into 80 for training and 20 for 80 for training and 20 for testing using random states of 42 reproduction. Here we go to training and testing. We now move to StandardScaler. Before training the model, we scale the numerical features using StandardScaler. This transforms each numerical column so that it has a mean of 0. Mean of 0 and standard deviation of 1. This is important because logistic regression is sensitive to the scalar of input features. Note that we only scale the numerical columns. The encoder categorically columns are left as they are. Move to training the model. Now we train the logistic regression model. We set max time to 1000 to give the solver enough iteration to find the optimum coefficient. The model is fitted in our training data, X train and Y train, and we get confirmation that it is trained successfully, as it is. Next, we move to evaluating the model. This is the most important cell for model evaluation. We use the trained model to make prediction on the test set, and then print the classification report. This is the classification report on the screen. The report shows the precision, recall, F1 score, and both classes rejected and approved. The overall accuracy of the model is written at the bottom. This tells us what percentage of loan application the model classifies correct. Good to say that here, the confusion matrix. This confusion matrix gives us a visual breakdown of our model prediction versus the actual labels. The rows represent the actual values rejected and approved, and the column represents what the model predicts. The dialog cell shows correct prediction, true negatives and true positive. The dialog cell shows the error, false positive and false negative. Yeah. Now we move to ROC curve and AUC scores. The ROC curve plots plots the true positive rate against the false positive rate at various threshold settings. The AUC, which means the area under the curve, summarizes this into a single score. A score of 1 is perfect, and 0.5 means the model is no better than random gazing. Our model achieves ROC-AUC score that shows it has meaningful ability to distinguish between approved and rejected loan application. Feature importance. Finally, we visualize the feature importance using the coefficient for the logic regression model. Green bar, this one represent features that push the prediction towards the loan approval, while the red bars represent features that push towards rejection. From this chart, we can clearly see the edge guarantors membership years having the most strong influence on the model prediction, while credit history and repayment type defaults also play a significant role. As we conclude now, we have successfully built a logistic regression model to classify SACCO loans application as approved or rejected. The key steps included handling missing values using median manipulation, encoding categorical values with LabelEncoder, scaling numerical features with StandardScaler, and evaluating the model using accuracy, classification reports, confusion matrix, and not forgetting the ROC-AUC score. The most influential features were credit and history payment defaults were the most influential features. A member's past borrow behaviors is the strong signal of whether they will pay a new loan. Thank you for watching. See you next time.